Hi class, Professor Smith here. In this image, we have a concave lens, which has a shape that's thinner at the center and thicker at the outer edges. And one of the properties is that it causes light rays to spread out or diverge when they pass through it. That's why concave lenses are commonly used to correct nearsightedness or myopia in contact lenses and in eyeglasses, as they help spread out the light rays before they enter the eye. The surface of the lens are uniformly curved like a bowl that holds water. And in lesson 4.1 on concavity and points of inflection, we'll see how the word concavity relates to the curvature of the concave lens. Before we begin with this application of the second derivative, recall we showed that the first derivative can determine when a function is increasing or decreasing. Now we'll see how the second derivative is related to the concept of concavity of a function. So let's get started. Let's first begin with the definition of concavity. Suppose that f is differentiable on the interval AB. If f prime is increasing on the interval AB, then the graph of f is concave upward on AB. If f prime is decreasing on the open interval from A to B, then the graph of f is concave downward on AB. Now, if the graph is concave upward, we also say that f is concave upward. And similarly, if the graph is concave downward, we say f is concave downward. Alternatively, we can think of the function being cupped up when it's concave up, and we may say that it's cupped down when it's concave down. And in our image on the right, you see that f is concave up to the left, or it holds water like a bowl, and that's to the left of A. And recall, our concave lens was bowl-shaped, that concept of holding water. So if it holds water, it's concave up. And where is it concave down? You got it, between A and B, since that is where our bowl spills water as opposed to holding water. And we also see that it's concave up to the right of B, where it holds water. Now that we have shared the definition of concavity, and the intuitive idea of concavity, of holding water or spilling water, let's share the relationship between the second derivative and concavity. Suppose that f is a function, and f prime and f double prime both exist on the interval from A to B. If f double prime is greater than 0 for all x in that open interval from A to B, then f prime is increasing and f is concave upward on the open interval from A to B. Number 2, if f double prime is less than 0 for all x in the open interval AB, then f prime is decreasing and f is concave downward on the interval AB. Now for points of inflection. By definition, if the graph of a function is continuous and it has a tangent line, possibly vertical, and the graph changes concavity at that point, then the point is called a point of inflection. Case 1. We have a graph here and the inflection point with the slope of the tangent line, and it's not 0. In fact, it's sloping upward. In our second case, we have an inflection point where the concavity is changing from upward to downward, but here we have a horizontal tangent line. And in case 3, we have an inflection point with a vertical tangent line. The concavity is changing, but the tangent line is vertical. Thanks for watching an introduction to concavity and points of inflection.